Hello everyone. Welcome to our presentation about how to test security mechanisms with real IT and OT scenarios. My name is Matan Doboshin. I am the head of research here at OTORIO. With me I have Idan.
Hello everybody, I'm Idan Helzer. I'm from Matan's team and I'm a cyber analyst.
And we both work at OTORIO, which is a next generation OT security and digital risk management solutions provider. Our motivation for this project was to automate the way that we test security products, because this is a major part of our day-to-day job in integrating with those products. Before I begin, I would like to thank Otis Alexander and the rest of the team from Maitre for their great feedback and supporting this project. And also big thank you for Daniel Lugel from the incident response team here at OTORIO, which implemented most of the attacks you're going to see here today. But you have other motivation to test your security products. Before you're buying one, you need to make sure it answers your success criteria. Also, every once in a while, you need to test that the security products you already have are still operational and stopping attacks from occurring in your networks. And you need to test your security products to confirm the functionality they're supposed to do. It doesn't matter if it is an antivirus, EDR, firewall, or some kind of intrusion detection system. But in the same time, you don't want to drown in all the alerts. Alert fatigue is one of the most frustrating things there are. But the real bottom line of the success criteria you should have when you're choosing a security product is it should stop attacks that concern you. And you need to be able to define custom scenarios for your environment and execute them to make sure the security product is doing what you paid it to do. And the only reliable way to make sure that is by running live attacks on your environment. And this will bring some challenges and requirements. First, the actual environment. It will cost some resources to buy endpoints, controllers, servers, etc. Also, if you want an OT network, you'll need some automation knowledge, and it will cost even higher price because the lack of virtualization tool and OT simulators. And the most frustrating point is very little is known because our all OT risk management is based on like 4 or 5 previous published events. And most POCs I know only include a couple of indicators that already been published in the past, like a TriSys executable or some IOCs from a different attack. And of course, a security product will stop something that already been published. But what are the odds that an attacker will use the exact same payload twice? So we're going to cover a couple of topics. First, the environment and the emulation tools that will help us automate the testing phase. Second, how we developed OTTTPs, techniques, tactics, and procedures. And finally, how we combined one of the emulation platforms with the OTTTPs we created in order to generate industrial attack scenarios to test the security products with. So starting with the environment. You need some lab to run the attacks on. In most cases, you don't want to run live attacks on your network, especially if it is an operational one. And this is a big topic. You have a lot of different possibilities to set up an OT testbed. We really recommend you to read this paper if you're interested in this topic. But the real bottom line is the lab you're testing should be as realistic as you can afford to your operational networks. Just to give out the big picture, the spectrum of setting up an OT testbed varies between a very simple and virtual environment with some open source OT protocol simulators. It goes all the way to mixture of virtual and physical environment with real multiple physical OT processes with central logging and etc. Our lab is somewhere around the fourth column here. Here you can see a graph of the environment we are going to test on. Top down, here we can see the security servers we are going to test. We have different kinds of them, antiviruses, EDRs. We have some firewalls here with monitored agents behind them. And we configured all the management servers to forward the logs to our central logging, which we use Elasticsearch. This way, after we run the attacks, we can go to one central place and see all the logs from all the servers and how they reacted to the attacks. Here we can see another virtual segment we have with some endpoints and servers. This will help us simulate some lateral movement between the different segments we have. And on the bottom, we have our two OT physical labs with various OT infrastructure from different vendors. And these labs, we configured a span port on two OT firewalls we have in the entrance of each subnet. And we have two top-tier industrial intrusion detection systems that are monitoring this span port. Now that we have an environment, we have different possibilities for emulation tools that will help us execute live attacks on the network. And the emulation tools divided into blue and red team tools. I'm sure most of you know at least the red team ones like Metasploit or Nmap or PowerSploit. And these guys here did a great comparison of most of the possible tools that are out there. And we summarized most of their work to this table here. When we chose emulation platform, we had a couple of mandatory requirements for our project. The first one, we needed an interface framework because we didn't want very high-skilled researchers to use it, not only. Also, we wanted to make an industrial version of it. So adding procedures or abilities was a mandatory requirement also. And you can see here that Caldera has by far the most comprehensive offering of all. And we've been using Caldera for a few months now. It really satisfies most of our needs. Also, the fact that it is open source and it is Python based makes it really easy to extend and write plugins to. Let's talk a bit about Caldera. Caldera is an open source advisory emulation platform developed by the Mitra team. Its original purpose was to help execute autonomous exercises for blue and red teams. The fact that it is built on top of the Mitra attack metrics makes it really easy to create custom scenarios that concern you and run them on your networks. Before I show you a quick demo of Caldera, let's go over its terminology. First, an agent is just a simple program you execute on one of your endpoints or servers. It connects to the Caldera server and gets instructions to run. And the group is just a collection of agents. You can group together by some purpose, like all of your servers or all of your endpoints. An ability is a specific attack technique implementation. So you can think of it as some kind of reconnaissance script, for example, or a specific privilege escalation exploit. An adversary is a collection of abilities run one after another. And you can think of it as some kind of malware that has a lot of abilities inside. And an operation is just a one-time execution of some adversary on a single group. Now I'll give a quick demo of the Caldera interface. I hope you can see it. Here on the main dashboard, we have a couple of tabs. If we'll open the Agents tab, we can see the live agents of Caldera. We can send instructions to run. If we enter the Adversaries tab, we can see the existing adversaries we have. And you can see the different phases and abilities that are inside. And this is how I add new ability to an existing adversary. You can see here the attack mapping here. So it's super easy to add new abilities. And by that, creating custom scenarios to test upon some use case. Now that we have an environment and we covered what emulation platform we will be using, we needed to make it industrial somehow. And really the first data source we approached was the attack for ICS. I'm sure most of you know it, but just in a few words, attack for ICS is the OT version of the MITRE attack metrics. It introduced dozens of new industrial native attack vectors that we can implement later on Caldera. And the attack for ICS was a great starting point, but the attack for ICS only summarizing previous attacks. And we didn't stop there. And we did research about different possible attack vectors we maybe gonna see in the future. One example is the exploitation of control systems like DCS or SCADA systems. And we implemented some techniques that will do exactly that. Idan will show it in a demo in a few minutes. From the technical side, we created standable executable for each of the abilities we developed, and it was mainly written in Python. Okay, we covered all the background to the project. Now I'll give Idan the stage to show you the first industrial version of Caldera.
All right, so thanks, Matan. And now let's go to the part that you've all been waiting for and see the actual OT abilities that we have developed on top of Caldera. Nice. So what you see here are 80 new ICS-oriented abilities that we have developed. We don't know any other attack platform that simulates this amount of OT abilities, and we think it's a pretty good start for now. So we divided the abilities that we have developed into 3 logical categories. The first category is discovery and identification of industrial devices, where we use OT protocols to gather basic information on devices in the net, which are industrial. The second logical category is OT interference, where we disrupt OT processes in the factory. And the last logical categories of ability that we have developed is industrial data collection, where we use OT principles in order to gather some more complex data from the web, such as OPC tags, or gather code that runs on PLCs and things like this. So what we did with these abilities is to create some adversaries in Caldera. And what we'll do now is see 3 of these adversaries and see how well did these adversaries perform. So the first adversary we'll see today is OT Discovery, which is a noisy reconnaissance adversary. OT Discovery starts with doing an industrial port scan to discover which hosts in the subnet are listening on industrial ports. In the second phase, it uses OT protocols such as S7 and Ethernet IP in order to discover basic information on PLCs in the network. And in the end, it tries to find default credentials of scalences, which are switches from Siemens, using both Telnet and HTTP. The second adversary we'll see today is Mini Stuxnet, which is a tribute to the legendary Stuxnet. When designing Mini Stuxnet, we thought of PCS 7 environment, which is a DCS from Siemens. And the way that a PCS 7 environment is built is that the engineer is copying project files of Siemens to an open SMB share in the network. So what this adversary do is to search for SMB shares in the network. It then scans them for industrial files. In parallel, it does an S7 scan, just like the OT discovery, to discover PLCs in the network which listen and communicate with S7. And in the end, it tries to stop the PLCs that communicate with S7 in order to disrupt the OT process. The last adversary we'll see today is Modbus Destroyer, which is an in-destroyer-like scenario. It starts by doing a Modbus scan. Then it queries coils of the PLCs that it found to discover which coils are up or down. In parallel, it tries to find and upload code from PLCs, code that's written in ladder logic, the actual logic that runs on the PLC. And in the end, it also tries to disrupt the OT process by doing both brute force attempt on the PLC and write multiple coil values to the PLC, and send illegal Modbus function code, which in our experience sometimes disrupt the way that the PLC is working. So we've discussed these three adversaries, OT discovery, Mini Stuxnet, and Modbus Destroyer. And now let's go back to Caldera and see how well did these adversaries perform. So once again, this is Caldera. If I want to run an operation in Caldera, I can choose the operations tab and add new operation, give it a name, and choose on which group of agents I want to run the operation on, and with what adversary. For example, OT discovery, which we have just discussed. So before this presentation, I've already ran all of the adversaries in order for us to save some time right now. But let's see the output of each of the adversaries that we've used. So the first one being OT discovery, and we can see its operational output over here. What we see here are the phases of the adversaries going from the bottom up. We can see it started from the industrial port scan, finished with the default credentials check. And over here, in these stars, we can see the output of each command. So for example, if we'll take a look on the S7 scan output, we can see that the S7 scanner scanned 2 subnets. It discovered that these hosts were alive, and it also discovered 3 hosts that communicate with S7. PLCs that now we have basic information on them. So we have the PLC module name, the type name, the serial number, as well as the rack and the slot that each PLC has answered to us in S7. If we'll take another example on the Modbus scan, we can also see which hosts were alive in the network that the Modbus scanner scanned. And then we can see that one PLC gave us some basic information, the vendor name, the product code, and the product version. Let's take a look on the actual machine on which the attack was happening on. So this is a remote virtual computer on which the agent is running. And what you see here is a network capture from the time of the attack. So what's nice is that until now, Caldera, that was only supporting some IT protocols and IT procedure, can now support OT procedures and create, as you see here, some Modbus communications, or for example, S7 and Ethernet IP, which is nice. So now let's go to the second adversary, Mini Stuxnet. Here is the operational output, and what we see here is firstly the SMB shares discovery, and we can see that the SMB share was found in this IP. It then scanned for S7 PLCs, just like we've seen in OT discovery. And in parallel, it tried to find industrial files in the open share. And we can see that it found an industrial file with the PLF extension, which is part of Siemens's project files extensions. And then it copied it to the working directory. And in the end, it sent multiple stop requests to the PLC using S7 in order to disrupt the OT process. The last adversary we've discussed and we'll see right now is Modbus Troyer, which started with a Modbus scan, just like OT discovery, then queried the coils, and we can see which coils are up and which coils are down in the memory of the PLC. And then it uploaded the Schneider logic from the PLC to our working directory and interfered with the OT process using brute force and illegal Modbus function codes. If we also take a look on the network capture from the time of the attack, we can see just that the caldera initiated the attack and then used read device and identification request in order to gather the basic information that we have just seen inside caldera. Then it read the PLC's coils. Then it used Unity, which is Schneider's somewhat like Modbus protocol, to upload the logic from the PLC to the working directory. And in the end, as mentioned before, it wrote multiple values to the PLC using multiple packets, as you can see in this network capture, and then finished executing the attack with illegal Modbus function code. All right, so what we've seen here are these three adversaries, OT discovery, Mini-Stuxnet, and Modbus Troyer. And now that we've seen our adversaries in action, let's talk a bit about what we should now look at when trying to see logs and monitoring devices that we own. So let's talk a bit about logging and monitoring. After executing live attacks, we would probably want to search for events from the time of the attack. So we use ELK, as Matan mentioned before. It's Elasticsearch, then Logstash, and on top of it, Kibana, which is the GUI that you see right here. And in this system, we can see logs from various security appliances that we use. So there are some basic events that we'd expect every security appliance to detect. For example, here we can see IDSs recognize a port scan, which I'd expect every IDS to detect because it's basic. But then we probably want to talk about what depth is this security appliance giving me on event that occurred. So for example, here we have two EDRs, and both of them documented an event of copying file from an SMB shell to my computer. One EDR has mentioned just a file copy was done. Another EDR is telling me that a PowerShell script was copied. Now, it's greater depth, and it gives me more context to the event that happened and lets me, as a CISO or security analyst, have more knowledge about the attack that happened. So when choosing security products, note the depth of their understanding of the reality. Now, the last thing that is interesting when considering ICS security is can our security appliances detect and understand OT principles and protocols? So what we see here is an IDS that not only recognized that there has been communication with S7, as we can see in the upper right corner, we can also see that it detected that a PLC stop command was sent. And also we can see that it mentioned when a computer downloaded or uploaded code to or from a PLC, which is nice and less trivial when talking about ICS security. So to summarize up this point, when discussing on live attack scenarios, you should run and execute attacks that concern you, and then go to your logging system. If it's either a central logging or a GUI of the specific security appliance, you should search for events from the time of the attack. Now, if you did not find any, maybe you should try to configure your security appliances better and see if you can, in a way, detect more of the attacks that concern you, changing the way that the security appliance works. Now, if you've gone through all of the documentation and asked the company and they can't help you, maybe you should consider a better security product or a security product that will better fit your needs. So now for some final conclusions and summary, I want to give the stage back to Matan. Thanks for listening and see you next time.
Okay, hi again. We almost reached the end. So to this day, as Idan showed you, we developed 18 new OT-oriented attack vectors and abilities, and we summarized them into various scenarios. Today, we only showed you 3 of them. The last part of Idan's presentation was the actual testing of security products. And unfortunately, I can't share with you the names of the vendors or the actual results of how one did better than the other or did much worse than the other. But let's just say there is a strong competition between those all. And not all of the security products that were meant to find something actually detected or prevented it. This is the reason I strongly recommend and believe you need to do at least the bare minimum by testing your security products. You don't need such an environment like ours or to use OT Caldera. You can run simple things like Nmap reconnaissance scripts or some ICS modules from Metasploit and see how the system reacts to that. This is an ongoing project of ours. We're planning on multiplying the number of abilities in the few weeks or months now. We are inviting you to stay in touch with us and hear about this project in the future. Now a point a lot of you have been waiting for. Will we publish all of the abilities you saw here today for everyone to use freely on the web? And this is a point we thought about a lot in the last few weeks. I think this question is bigger than only this project, because in the last few months, there has been a lot of criticism around publishing open source penetration or red team tools for everyone to use freely. Because of the extreme ease of use, as I mentioned, these are standalone executables that are doing that can do a lot of operational impact. We will not publish them freely for everyone to use, but if you are some research institute or you have some part in the good side of the ICS community, we're inviting you to contact us and get more details or maybe collaborate in the future.